So today we're going to begin talking more about algebraic phrases, being able to write an equation from what we say or what we see on a piece of paper that isn't mathematical. It may be like a real life situation where we need to actually make something. So on page 125 there is a long list of algebraic phrases. Now these are just algebraic phrases. They're not complete sentences. And I want you to notice that at the end of each one, look carefully at the end of each one, is there a period? No, because they're not a complete sentence. So the first one says the sum of a number and 7. So when you hear the sum of something, what are we telling you? Yeah, we're going to add them together, right? So the sum of some number and 7, it could look like this. Could it also look like this? Would it make a difference? Wouldn't make a difference, would it? When we're adding, does the order matter? No. Commutative property tells us it doesn't matter. However, if it said the difference, of a number. So this number is just some number, doesn't matter what it is, and we usually use n for some number, although you could use x or any variable you like. The difference of a number and 7. What does difference usually tell you? Subtract. Find the difference between two things. So here's the difference. Would this work as well? Okay, so let's say the number that we actually are talking about, let's say it's your age. Okay, everyone think of your age right now, whatever it is, 12, 11, something like that, right? 7 less than your age. Start with your age, subtract 7. Got it, right? Can you start with 7 and subtract your age? Does that work? It doesn't work, does it? Okay, so subtraction is not commutative. You can't do it in any order that you like, and it really makes a difference in what order you write them in. So we have to be very careful about that when we're doing any kind of subtraction type of thing. So when it says 7 less than a number, I get a lot of kids that want to write this. 7 less than a number. Is this 7 less than a number? No, it's when we write it this way, it's a number less than 7 is what we've actually written. We have to write 7 less than a number like this. And we have to start with the number, and then we have to take 7 away. And it's confusing because when you read it, it starts out 7. What do you want to write down? Nobody knows. 7. Yeah, you want to write it in the order that it gives it to you, right? Knows. So you got to be really careful about that. Whenever it's 7 less than something, we've got to make sure that we start with the something and then take 7 away. If it's 7 more than something, can we get away with doing it in either order? We can. Okay, but when it's less than or a difference, we have to be really careful about that. How about, okay, so a number, some number, n. What about the opposite of this number? Yeah. Or the opposite of n. That's the opposite of n. Let's see, the opposite of a number, decreased by 5. You okay with that? Okay. Okay, let's keep going on down. The sum of the opposite of a number and negative 5. Same thing. What does sum mean again?
Addition.
What does sum mean?
Addition.
How come only one of you knows that?
Addition.
2 of you. What does sum mean? Addition. Okay. So it says the sum of the opposite of a number and negative 5. We write it down. You guys see addition here anywhere?
Yeah.
Where's the... Oh, yes. Someone's thinking. Where is it? Yeah, we're adding a negative number. So, truly, when they say the sum of the opposite of a number and negative 5, this is what we're talking about. Are we ever going to write it this way? Could we?
Yes.
Yeah. Okay, but this is just easier, isn't it? So when you see this word, the sum, you don't just automatically put addition symbol down. Okay? Because if I'm adding negative 7, I don't want to put plus negative 7. So you have to read the whole thing, and you have to be careful about what's going on. What about product? What does product mean? Okay, so the product of some number and 2 here. The product of some number and 2. Is that fine? What? Dead silence.
It's backwards.
Okay.
Backwards.
But it said the product of a number and 2. Oh well. Right. You know. Yeah. You know, when we were doing problems the other day, and it said, what fraction of 30? What fraction of 30 is 40? Well, I didn't write down F30, did I? For what fraction times 30? Is that what I wrote? Dead silence. Is that what I wrote?
No.
No. What did I write?
30F.
Yeah, we wrote 30F. And then is 40. I want you to notice something else about this. See how this one's a complete sentence? Right? Notice when we write it, see how it's a complete equation?
Yes.
Okay? Notice that we don't have a period, but we do have a question mark at the end. It is this. None of the ones we're looking at today on the bottom of 1 to 25, they're not complete sentences, so they don't make a whole equation, do they? Later on, can you imagine, I might give you one of these and then say, it is something, where it actually makes a full equation that you have to solve? Oh. Yep, that's coming. But fortunately for you, not today. Let's just keep going down through here. Can you guys find the one right in the middle that says the sum of twice a number and negative 5? See that? So I'm supposed to take twice a number, and I'm supposed to take negative 5, and what am I supposed to do with them? Add them together. Okay. So I guess I could do this, but I'm not going to because I'm way too lazy. And so is every other mathematician in the world. Okay, even though it says the sum, okay, if I'm adding a negative number, I'm just going to say subtract 5. Okay, and then there's one more that I really want to focus on. See where it says 6 times the sum. 6, and I'm going to put this in red. Six times the sum of the opposite of a number and negative 8 or negative 5.
Negative 8.
We'll do that. This times the sum, this particular phrase right here. Whenever you see that, you have to think, okay, distributive property. I have to multiply 6 by the entire sum, not just by the opposite of the number, not just by the negative 8, but by the whole sum. And every time you see this particular phrase right here, this is what you're going to do. You're going to write 6 times the sum. Oh, parentheses. And you're going to put that sum inside the parenthesis. The sum of the opposite of a number, here's opposite of a number, and negative 8. Once again, am I going to put plus negative 8? I could, I guess, but I'm not going to. So, see how this is 6 times the entire sum? It's not just 6 times the opposite of the number or just 6 times negative 8, but both of them. This phrase, can we burn it into your brain? How many times do you think I'm going to say this to you in the next 3 class periods?
Probably 10 to 12.
1,000? 1,000 then? Okay, we'll go for 1,000. Do your absolute best on these. Ask me questions. It's not going to be the easiest thing ever, but you can do it. So let's just practice a little bit. And there's only so many ways to say things, and so many phrases that you really have to learn. And you're very quickly going to catch on to how it works. They're not really that bad. So let's turn over to page 126, down at the bottom on the practice bit. You guys see practice? Okay. So practice A says 5 times the sum of 3 times the number and negative 5. I want you to do your best to write out what that says algebraically. And I will walk around and laugh at your tries. No, I will be very nice and try to help you as much as possible. Don't overthink it. Don't just sit there frozen up. Just do your best. If you're wrong, it's going to be okay. You're going to figure it out. Sometimes we learn more from being wrong. Trust me, I'm wrong a lot. Yes, ma'am?
You want us to solve it?
You can't, because it's not an equation. See that? Do you guys get that? She was saying, do you want me to solve it? Does it equal anything yet? Okay, so all we're doing is writing down what the phrase says. It's not an equation yet. It will be later, but for now we just want to write out the phrase and get used to that a little bit. Okay, you got it? 5 times the sum. Did that burn into anyone's brain yet? Did you put 5 and then make a parenthesis?
Yes.
Okay.
Yes.
3 times the number. So here's 3 times the number. And here's negative 5, and I'm going to add those together. That's the sum that I'm supposed to multiply 5 by.
So that's the answer.
Okay. Once again, does it say it is anything? Does it say it equals anything? No. This is not an equation. All you're doing is writing down what it says algebraically. So you're changing it from an English sentence to an algebraic sentence. That's it. Okay? So that's all you have to do. B, try it. The product of 3 and the sum of a number and negative 5. What does product mean? Multiplication. If you want the product of 2 numbers, then we're going to multiply them together. I got to tell you, this one's sneaky hard, and I don't even know why we usually don't say it this way, but we'll see how you do. Okay, so the product. What does product mean? Okay, so we need to multiply 2 things together. And I see 2 things here. The product of 3, so I got a 3, and the sum of a number and negative 50. So I have some number and negative 50 that I'm going to add together. And I need to multiply these 2 things together.
Oh, crap. Okay, I read that wrong.
So it seems like, and I'm guessing a lot of you wrote this.
Yep.
Yeah?
Yep.
Okay. This is only the product of 3 and a number, and then add the negative 50 later. See, it says the product of 3 and this whole thing. So if we're going to have 3 times this whole thing, we've got to have parentheses so that we use the distributive property, don't we? Nah, it's the same as times the sum, isn't it? It's a sneaky one though. You're going to do better on C. Go.
I got that one right.
Oh yeah.
Congrats.
Now this does not say times the sum. I'm just saying, I don't see anything there about times the sum. Okay, so on C I see 2 things. I see 5 times the number, and I see the negative 13, and what are we supposed to do with those 2 things? We're supposed to find the sum of them, which means what? Add them together. Okay, that's it. That's it. It literally says this. The sum of 5 times the number and negative 13. Are you guys okay with that?
Yeah.
Same thing? Okay. One more. Let's try D. 3 times the sum! Just saying.
Just yelling.
Just yelling.
What the heck?
I can't look at the whole thing at once. I just have to do a little bit at a time.
This one's confusing.
So 3 times the sum, right?
Yes.
So I would do that. Of the opposite of a number and negative 7. So I have the opposite of a number and I have negative 7, and I'm supposed to add them together and times the answer by 3.
I got that right.
I got right.
Who did it? Woohoo! Awesome. Okay, now let's talk about these decimal part of a number problems. We've already done them. Remember the problems I said, what fraction of this, right? Or is what fraction? Aren't fractions and decimals the same thing? In fact, don't we call them decimal fractions sometimes? It's a fraction of a whole, isn't it? So when it says 0.32 of what number is 24.32, our job is to write this out as an equation and solve it. Now this is an entire equation. It's a complete sentence. Okay, so it's a full equation, and we just write down 0.32. What does this mean? Of what number? Times n. Times some number, we don't know what it is. Is, what do we put for is? Equals. Any question about how to solve this? Are you glad you can use a calculator now? Okay, so all I need to see is that you write out the equation, you divide both sides by 0.32. I want to see that. I want to see that these cancel and give you 1 times n. And then it's okay to do this bit on a calculator. So we can get out our calculator if we like, 24.32, although they're always kind of easy. Divided by 0.32, and just comes up to be 76. And then your last job is to think about, is this a reasonable result?
Yes.
0.32. Isn't that about a third of something? Can you picture in your mind a third of something? A third of 76 is 24. I mean, if you have 3/4, the 75 cents, a third of that's 25 cents, isn't it? Okay. Is that a reasonable result? Okay, then you almost certainly did it correctly. Okay, if you do it incorrectly, your result will not be reasonable at all. Here, write this one down for me. Write out the equation. Don't solve it yet. Just write out the equation. It should just take 10 seconds. Okay, that's 10 seconds. What did you write when it said what decimal? Okay, do we know what the decimal is? Do we know what decimal we're talking about yet? So we need some symbol that represents some decimal, but we don't know what it is yet. What could we use to represent some decimal that we don't know what it is yet? A D! Holy crap! A D! You guys are brilliant! Could we use an X?
Yeah.
Yeah, we could use whatever, but we're going to use D. Okay? What decimal part of 42? What does that mean? Of. What does of mean? Multiply 42. Okay? Now, how about that? That work? Everyone good with that? All right, we're past that. So 42D. What does this mean? Equals 26.04. How can we find that decimal? Yeah, now we divide both sides by 42. This cancels and gives us 1 times D. Thank goodness for calculators. 26.04 divided by 42 turns out to be 0.62. 0.62. Let's see what this says. It says 0.62 of 42 is 26. I'm going to think of this as a little more than half. 0.62. Is that a little more than half? What is half? 0.5. There's a little more than half of 42 is 26.
Yeah.
Yeah. Got it. Okay, let's try another one.
A fraction number.
Yeah, they're exactly the same. What fraction, what decimal. They're the same. We're just giving our answers as decimals rather than fractions.
I like decimals more.
Do you?
Yeah. Fractions are just too hard for me.
You know, there are times when fractions are so much easier, and there are times when decimals are so much easier. I gotta say. Okay, write out the equation. This one's a little weird. 0.42 should be done by now. What does of mean? Of time. Times 86. Times 86 is equals some number, n. Now this is a little weird. This isn't like, we don't have to divide both sides of the equation here or anything like that, do we? We just have to literally go 0.42 times 86. Can we use a calculator for that?
Yes.
We can. 36.12 is the number. So this says a little less than half, you with me? A little less than half of 86 is 36. Yeah. It's reasonable, isn't it? Okay. So are these exactly the same as the what fraction problems? We're just, yeah, we write the equation out the same. We're just giving decimal answers, and we have decimals in the problem rather than fractions. That's it. I like the what fraction ones because I never have to use a calculator, or rarely. So I guess I could do this without a calculator too, couldn't we?
Yeah, we could, but calculators are easier.
I mean, I hope we all can do this, right? Can we multiply? I think we could make that happen. Let's see, 12, 16, 17, that's 24, carry the 2, that's 32 plus 2, that's 34, 2, 1, 5, 6, 3, got a couple decimals. Hey, we could do that, couldn't we? Can you all do that? I hope we can. Okay, set 30, let's get it done in class and have no homework this weekend.
Okay.
Okay. Enthusiastic yes from everyone.